Hello everyone. In the previous classes, I have discussed refraction. Now I am going to discuss laws of refraction. Okay. As you know, the bending of light at the interface due to the change in velocity of light is known as refraction. Okay. So this is incident ray. As you know, this is refracted ray. Okay. And this is normal. Okay, then what does the first law tells? First law tells the incident ray, the refracted ray and the normal to the interface all lie in same plane. Okay, all lie in same plane and that plane is perpendicular to the interface. Okay, so I am going to write the first law of refraction. The incident ray comma the refracted ray and the normal to the interface all lies in same plane. Okay, all lies in same plane and that plane is perpendicular to the interface. Okay, so this is all about first law. Then what is second law? Second law is also called as Snell's law. Okay, so suppose the velocity of light in medium 1 is v1 and velocity of light in medium 2 is v2, and let the angle of incidence is theta 1 and the angle of refraction is theta 2. Okay, what does the Snell's law tells? Snell's law tells that the velocity of light in medium 1 divided by sine of angle in medium 1, velocity of light in medium 2, and it is divided by sine of angle in medium 2. Okay, this is the first form of Snell's law. Okay, here we can tell that there are four variables, that is v1, v2, theta 1, theta 2. Okay, if I know three variables, then I can calculate the fourth variable. If I know velocity of light in medium 1 and velocity of light in medium 2 and theta 1, that is angle of incidence, then I can easily calculate angle of refraction. Okay, from this equation I can calculate angle of refraction. Now I am going to discuss the second form of Snell's law. Okay, before going to second form, we have to know what is refractive index. Okay, what is refractive index? It is represented by small n. I am going to discuss the refractive index with some examples. Okay, you know, refractive index of glass with respect to vacuum is 1.5. That means the velocity of light in glass is 1.5 times slower than the velocity of light in vacuum. That means velocity of light in glass is 1.5 times slower as compared to the velocity of light in vacuum. Velocity of light in vacuum is c and velocity of light in glass is 1.5 times slower. So I am dividing 1.5. Okay, so c divided by 1.5. 1.5 is refractive index of glass. Okay, so velocity of light in any medium is defined as the ratio between velocity of light in vacuum and the refractive index of that medium. Okay, if the refractive index of medium 1 is n1 and refractive index of medium 2 is n2, then I can write v1 is equal to c upon n1 and v2 is equal to c upon n2. Okay, from this rule I can write v1 is equal to c upon n1 and v2 is equal to c upon n2. Okay, and from equation 1 I am going to replace v1 and v2. So from equation 1, as you know, equation 1 is v1 is equal v1 divided by sine theta 1 is equal to v2 divided by sine theta 2. Okay, in place of v1 I am going to place c upon n1, c upon n1 sine theta 1, that is c upon n2 sine theta 2. Okay, n1 sine theta 1 c upon n2 sine theta 2, and c will be cancelled out. Okay, and if I take the reciprocal, then it will be n1 sine theta 1 n2 sine theta 2. This is the second form of Snell's law. Okay, and as you can see, there are also four variables, that is refractive index of medium 1 and the angle of incidence, refractive index of medium 2 and the angle of refraction. If these three variables, that is refractive index of medium 1, refractive index of medium 2, angle of incidence is known to me, then I can easily calculate angle of refraction. Okay, so thank you.